irrational numbers. Irrational numbers. Numbers. As we all know, irrational numbers are those numbers which are non-repeating and non-terminating. So numbers which are which are non-repeating and non-terminating. Non-terminating. Okay, so these numbers cannot be expressed as p by q. So now these numbers cannot be expressed as and not equal to p by q, where p and q belongs to integer. Okay, so suppose we want to say visualize this rational number in a number line. So what are the examples of rational numbers? First examples: pi is an irrational number, e is an irrational number, root 2 is a rational number, root 5 is, and so on. Okay, so let's say we have a number line, and this is 0, this is 1, okay, 2, 3, and we have minus 1 and all. So suppose I want to mark root 2. What do I do? So let's assume this is a y-axis, so this is 1, this is 2. What is 1 square plus 1 square equal to? It's 2, right? So what I mean is, if I draw a right triangle, with side 1 and 1, so I can use Pythagoras theorem, right? So by Pythagoras theorem, this is 1, this is 1, and this is root 2. So this length is actually root 2. Now if I draw a circle with that length as the radius, let's take some other color. If I draw a circle with that length as the radius, then it will intersect at this point, and that point is our root 2. So suppose the question is, say, prove that root 2 is irrational. So this question should be proved by the method of contradictions. That is, we first assume that root 2 is rational. So root 2 is rational. Then we use some logical steps to reach at a conclusion, which is nonsense. So since these steps are logical and this is nonsense, which means our starting point is wrong or this is wrong. So how do we do it? Okay, so let's assume root 2 is rational. Okay, so what is the specialty of rational number? It can be expressed as p by q, where p and q are integers, q not equal to 0, and p and q are coprime, that is their HCF is equal to 1. Okay, now I can bring this q this side, so that gives me root 2 into q equal to p, and if I square, I get 2q square equal to p square. So yeah, which means what? P square is even number, so 2 divides p square, which means 2 divides p. So p is an even number, and I can write any even number as 2 into some other number, right? So p equal to 2 into, say, some another number m. Now if I write this here, what do I get? I have 2q square equal to p, which is 2m the whole square, which is the same as 4m square. So I had 2q square equal to 4m square. 2 gone. So again we get the same. We have something similar like this. So 2 divides q square, which implies 2 divides q. So, and which means q is even. Q is even and p is also even. So 2 divides both p and q. So HCF of p and q should be at least 2 or some multiple of 2, which is not 1. So our this statement is wrong. So it is a contradiction to our assumption, and hence this statement is wrong, which means root 2 is irrational. Let's talk about rational numbers. Rational numbers. Okay, so rational numbers are those numbers which can be expressed as p by q form, where p and q are integers and q not equal to 0, and in the lowest form HCF of p and q is 1. These numbers are terminating, either terminating or non-terminating, but repeating. Examples are 1, 2, 5.5, 8.8888, so on, or 2 by 3, etc. Now suppose we have a rational number which is of the form p by q, and q is 2 power n into 5 power m, where n and m belong to whole numbers. Then we can say that a is terminating and a has max of m comma n, that is if whichever is maximum, that many number of digits to the right of its decimal expansion. Now let's think about why this is true. So I can write a as p by 2 power n into 5 power m. Now suppose n is greater than m. Okay, so if n is greater than m, then we have more 2's than 5, right? So I have to multiply by 5 to get the same number of 2. So if I multiply this by 5 power n minus m, 5 power n minus m, this is here, I will get p into 5 power n minus is some other number, say k by 2 power n into 5 power n, which is k by 10 power n. So from this we can say that k is some number, and from that number I go n places to the left, which means a has n digits after its decimal point to the right. Now what if m is greater? If m is greater, then you multiply by 2 power m minus n and we will get the same thing. Okay, now let's take a question. So let's say we have a number, say 5.898989 goes on. So how will I convert this into p by q form? So it's easy. Let's say this number equal to k. Now what is, if I multiply this number by 100, this point will jump to places. So what is 100k? 100k is 589.898989. Now notice this part and this part is the same. So if I subtract these two equations, then our decimal part vanishes. So I have 99k. I am subtracting, this is 1, this is 2, 1 minus 2. 99k equal to 584, or our k is 584 by 99. If you have any queries or questions on the subject, kindly write them in the comment section below. I will try to discuss the relevant ones in my next video. Also, welcome any suggestions on this video. Signing off, Madhu CS. Bye.